All right, y'all, let's talk about long division. So the other day I was working on a problem that dealt with synthetic division, and it got me wondering, what the heck is actually going on behind the hood of long division? So first, let's review what the heck long division is. How do we do long division? And then more importantly, what is it? Okay. Knowing what something does is how to do something is not the same thing as um, defining what it is, right? So we want to make a distinction, but let's start off with how do we do it? So back in the day when we learned this, probably like third or fourth grade when you first got exposed to this, what you do is you answer the question of how many times does 7 go into the first digit, or the digit in the tens place, or the 5 here, right? And so that goes in 0 times. So what we do is we move on to, we look at it as a 2-digit number. So we say how many times does 7 go into 49? And one way of thinking about this is, what number can I multiply 7 by that gets me as close as possible to 59, but not over, right? Um, and so what we can do here is, what we can say is, if this, let's call this this number here Q, right? And we say as close as possible, whatever's left over after getting as close as possible, we're going to call R. So what we can say is, what number times Q, I'm sorry, let me rewrite that. What number, which is Q, when multiplied by 7, so 7 times what gets me as close as possible to 59, and whatever I have left over, we're going to call it R, and that should give me 59. And when I say as close as possible, what that really means is that R has to be less than 7, right? Because if R was more than 7, then you would have another Q that you can put in, right? Another number that can go in one more time. So this right here, right, is essentially the equation that we're solving for. And in this case, we're saying, well, hey, it goes in 8 times, right? Right, and so how much is left over? Well, 7 times 8 is 56. And when we subtract 56, R is 3. So this is what's left over. So let's go back to this now, and let's think about, well, how do we naturally do this? Well, what we do is we say, well, hey, 7 goes into 59 8 times, because 8 times 7 is 56. That's this piece here. Then we multiply 7 times 8, right? And when we multiply that together, we get 56, and we subtract. 59 minus 56 gives me a remainder of 3. Right? So this formula right here, this little act right here, is essentially an equation of what division is. So the dividend, right, is equal to the divisor times the quotient plus the remainder. Move that over there, save a little more space to write the word remainder. Right? In other words, the number we divide by is called the divisor, right? The number that's being divided is called the dividend. By the way, easy way to remember this is dividend. If you read it left to right, you always end with the dividend, and you're always dividing by the divisor, right? 8 is called the quotient, and obviously with what we have left over, that's called the remainder, right? So isn't that what we did? This is the divisor times the quotient plus the remainder is going to give me the dividend. So this is an equation, but this isn't quite this is not telling me what long division is. And doesn't quite fully explain what the process of what we're doing, of what is going on. And for sure, things it doesn't explain when we're doing something like polynomial long division. What's going on, but it gives us an idea, right? Also, a lot of students struggle with their multiplication tables, and one thing that I always tell students when that happens is that if you don't know how many times 7 goes into 59, you just keep subtracting. So 59 minus 7 is 52. Subtract another 7, you'll get 45. Subtract another 7, you'll get 38. Subtract another 7, you'll get 31. Subtract another 7, you'll get 25. Subtract another 7. I think I made a mistake there. That's 24. I can subtract another 7. That's going to give me 17. Subtract another 7. That's going to give me 10. Subtract another 7. That's going to give me 3. Yeah, was that a little tedious, a little time-consuming? Yes. Was I going a little too fast? Probably. But what you can see after doing this is that we have 1, 2, 3, 4, 5, 6, 7, 8 times. Does it take a little bit of time to do this? Yes. But it does tell me that it's gonna work 8 times. And then, of course, how much do you have left over? You have 3 left over. And what's neat about this approach is it's literally answering the question of saying, how many times do I put, how many times do I have to subtract 7 from 59, right? This is how actually what I kind of like this idea of what division is. It's what are we doing? We're answering the question of how many times can I subtract the divisor to get as close as possible to the dividend. In this case, 8 times, and I got 3 left over. So this kind of gets me a little bit deeper, maybe a more intuitive, maybe not deeper, but more intuitive idea of what division is. But there's another sort of approach to this, another way of thinking about this, and that's that division. When we divide, numbers 59 divided by 7, right? 59 divided by 7 is the same thing as 59 over 7, right? So, or 1/7 times 59, right? These are different ways of saying it, and this kind of goes into, well, hey, what is division in another sense? And division is basically multiplying by the reciprocal. So now another question kind of emerges, which is, what is multiplication, right? Why when I do something, and I'm going to pick a different number here, but let's say I do 21 times 13, right? Why does this 1 times 3 is 3, 2 times 3 is 6, then put a 0, 1 times 1 is 1, 1 times 2. Why does this method, 163 plus 210 is 273, why does this method work? I mean, this is not algebra, this is just an algorithm that we use that produces the result. And so what's actually going on here is when we do 21 times 13, we are playing some game with digits, right? Because you're using this 3 as impacting the 1 and then the 2. So when you have a situation like this in mathematics, what we really are saying is that 13 is 1 times 10 plus 3. So if I give you this, for example, this number 273, we can rewrite this as 2 times 100 plus 7 times 10 plus 3. And this isn't just some trivial idea. This isn't just some esoteric game that I'm playing here. These are very useful rules. And so anytime you're playing with a digit, so for example, there's a rule in math that says, hey, 273 is what? Is 273 divisible by 3, right? Well, what you can do is if you add the digits, there's a rule that says if you add the digits, this gives me 12, because 12 is divisible by 3, that means 273 is divisible by 3. Now, it doesn't tell you what it is, but it tells you that it is divisible. So a question emerges from that, which is like, well, why is that true, right? You can't say it's true again because I tried one example, because just because it works once doesn't mean it works all the time. But if instead of saying 2, 7, and 3, I say the first digit is A, so 2 is A, then I can say A times 100. If the second digit is 7, instead of calling 7, I say B, which means it can be any digit, right? B times 10. And if I say the last digit is the ones place is just C, I can rewrite it as such. And then there's this really, really cool trick that we use all the time in mathematics. So first off, I'm going to rewrite this as 100A plus 10B plus C. And this trick that we do all the time in math is that we add and subtract, basically add 0. So we can subtract A and then add A because that's 0. And I can do the same thing over here. Subtract B and then add B because it's 0. You might wonder, well, that's true, but why are you doing that? What's the benefit of that? Well, this is going to give me 99A plus A, and this is going to give me 9B plus B with the last digit of C. And so what I can do now is I can group my 99A and my 9B together. And I can put the A plus B plus C together as well. And because I can factor now a 9 out of, or a 3 out of 99 and 9, I'm leaving with 3 times 33A plus 3B, we can say that, well, check this out. I can divide this by 3, and the 3 will divide out because they go evenly. We defined A plus B plus C as divisible by 3. So whatever A, B, and C is, it's going to go into 3 evenly. So because both of these, 3 goes into it evenly, right, then the number is divisible by 3. And a good way to determine, to see if you understand what I'm saying, I'm not going to tell you why here, but you can see why if you think about it. I also just now showed you this rule applies for 9 as well, so I'll let you figure out why that's true. This is a really cool trick here, is that this is also applicable when there's a cool digit trick when you have something like 13 times 11, you can just say, hey, take the 1 to 3, put those in the front and the back, and then when you add 1 and 3, you get 4, and this is true for any number that you multiply by 11. So like, for example, the common one that most people know is 11 times 11 is 121. Notice if you take the two ones, you put a 1 here, you put a 1 here, and 1 plus 1 is 2. And you can show that this works by using the same idea if you wanted to. If you want to see that, let me know and I can post that in another video. This discussion here is not just showing you a proof, just for the sake of showing you a proof, but it's going to apply later on. And this also shows us something else about division that I think is important, which is that dividing is really saying, if I can rewrite these, whatever I'm dealing with, as something times something, and I can make the numerator and denominator match, this number left over is going to tell me how many times it goes in. I find this definition of division, while it's difficult to say, is actually probably the most useful for thinking about long division. So why? Okay, let's go back to 59 divided by 7. So 59 divided by 7 is the same thing as saying what? 5 times 10 over 7 plus 9 over 7, right? I'm doing this game of rewriting 59 as 5 times 10 plus 9, right? So I can rewrite it divided by 7. I'm just dividing both those by 7. Okay. All right. That's fine. Now the question again here is, well, right, what did we do at the very beginning? In the very beginning, we asked the question of how many times does 7 go into 5, right? And so we try to do that here, and that's not going to work because 7 doesn't go into 5. If we think about this sort of definition of division, then we're saying, can I rewrite this 5 as 7? And the answer is no. I mean, well, we could, but as is, because it doesn't work, it doesn't go evenly, we're going to say we can't. So instead, this is going to give me, this doesn't work, so this is going to give me 0. So instead we're going to focus on 59 divided by 7. And I want to get as close as possible to a number that's divisible by 7 without going over, right? And we saw earlier multiple ways that that's going to be 8. 8 times 7 is 56. So what I'm going to do is I'm going to rewrite 59 as I want to be 56. So what I'm going to do is I'm going to actually do this. I'm going to add 56 and I'm going to subtract 56. Okay? And so what this does is I can put my 56 here. I can go over 7, and then I'm going to put the, right, so this 56 went here, and then these two are going to get thrown off to the side. And so now what we can do is we know that 56 is 7 times 8, right? And over 7, and then 59 minus 56 is 3 over 7. And so what happens here is the 7s, because they get paired together, this tells me that it happens 8 times, and then you have 3 left over. And this idea is exactly what's going on with long division. So, what the heck am I saying? Well, if we go back up here in the very beginning, when we do long division, right, notice here you have 59 minus 56. That stems from this right here, right? From the adding and subtracting 59 and 56 gives me 59 minus 56. That's where that subtraction is coming from. So, let's take a look now and play the same game, but this time we're going to do with polynomials. So give me 1 second. I'm going to pull up a polynomial problem here real fast. So let's say I give you m squared minus 7m minus 11 divided by m minus 8. So what I'm going to do here is I'm going to rewrite this as m squared over m minus 8 actually, I'm going to write it as m squared minus 7m over m minus 8 plus negative 11 over m minus 8. And what I'm doing here is we want to see how many times this m minus 8 goes into m squared minus 7m, but to do that, what I really need to do, what I'm really trying to do is get this and this to match. So, how do we do that? Well, if this has an m squared and this has only an m, why don't we multiply the top and bottom by m? Okay, and what this is going to give me is m times m squared minus 7m over m squared minus 8m. Okay, so we're trying to get, the project here is we're trying to get this to match with this, right? But we know a very cool trick, which is, let me write this as m times m squared minus 7m. Give myself a little space, m squared minus 8m. Well, if I need a minus 8m, well, I can just subtract 8m and then add 8m, right? I need an 8m, so I need a negative 8m. So I'll just subtract 8m and add 8m because that's just adding 0. So now I can rewrite this as m times m squared minus 8m minus 7m plus 8m all over m squared minus 8m. And what I can do now is I want to leave m squared minus 8m over m squared minus 8m together. This business is going to get moved over to the other side, so we have plus m times negative 7m plus 8m over m squared minus 8m. Let's not also forget that over here we still have this negative 11 over m minus 8. So let's bring that down. Plus negative 11 over m minus 8. Okay, so now we have m squared minus 8m over m squared minus 8m. How many times? Because this gets paired, we're left with m. So again, let's go back to the original example, right? Over here, because these paired, we're left with this. This value is, right, this value here, right? Let's talk about this with some long division here. So if I divide this the traditional way, minus 11, sorry about that. Right, what we do is we look at these two values and we say how many times does m go into m squared? We say m times. That's this m. Okay, so now we're left with m plus m times, now 8m minus 7m is 1m over m squared minus 8m plus negative 11 over m minus 8. Okay, so now what? Well, to play with these two, right, they got to be the same. So now, whatever I giveth, I can taketh. So I can divide through, or multiply top and bottom by 1 over m. And so now I have m plus, these are going to go away because they pair up together, m, and on the bottom I'm left with m minus 8 plus negative 11 m minus 8. Okay, now what do I want to do? Well, I want to play the same game. I need this to be a minus 8 so it can match with this one. So that's what we're going to do. We're going to subtract 8 and we're going to add 8 to create that effect. We don't really care about what's left over. Then I can rewrite this as m plus m minus 8 over m minus 8 plus and I could take this leftover 8 and make it hang out with the 11. 8 minus 11 over m minus 8. And again, the question is once this gets paired, what's this number left over? Well, we know that there's a 1 there. So now we're left with m plus 1 plus, and let's just subtract this out. 8 minus 11 is negative 3, m minus 8. Now let's see what happens here, right? So when I do this, we get m squared. We multiply this, and we get m squared minus 8m, right? And I feel like I wrote something wrong here, but we'll just keep going. So when we subtract and add, we get left with an m, right? Minus 11. We say, how many times does this go into this? So how many times does m go into m is 1. That's what's going on right there. And we get m minus 8, right? And so now we subtract, which changes our signs. Negative 11 plus 8 is negative 3. That negative 3 kind of freaked me out, but that's actually still correct. That was our remainder. That is our remainder. And that's what's going on with long division. We're playing this game of separating, of recreating it so that we pair the numerator and denominator together, and whatever number is left over, that's how many times it works. And I love this definition. This is actually a cool little insight. There's a lot of different ways of saying things, but I find this to be the most mathematically useful way of thinking about this. So maybe this is a little bit too in depth of a video or whatnot, but I think it's always good to see things with a little more depth. And these techniques, especially this technique of adding and subtracting, incredibly useful as you progress deeper into mathematics. So I hope you got some value in this. If you got some questions, comments, ways of me saying this a little bit more effectively, don't hesitate to reach out to me, and I'll see you guys in the next math video.